Okay, so the aim of this next video is to understand how a chi-squared test works and how to run it for data. What chi-squared is useful for is looking at the goodness of fit. It's sometimes called the goodness of fit or association test. So we need categorical data, so data that fits into categories, and then we can compare how well the observed data, so the data we've collected or the data set we've gathered, fits with the expected data set. Okay, so an example of where this could be really useful at the moment is there's been a lot of reports about how COVID-19 has caused a higher proportion of deaths in Black and other minority ethnic groups. So what we could do is we could look at the observed data, so the recorded number of deaths by ethnicity, and we could also look at the percentage of the population by ethnicity. So that would give us our expected data. And then by running this chi-squared test, it would let us know, is there a disproportionate number of deaths in any of those minority groups? Now, what it wouldn't do is it wouldn't tell us why that was. That would be a different question, but it would tell us whether or not there was a relationship between ethnicity or there was a fit between these categories. And then what we need to do once we run the test is we look it up on our critical values table for the number, and if our value we calculated exceeds the value, we'd look up in a table where we could say there is something else going on. This is not the expected pattern. For example, there is a higher death rate in Black and minority ethnic groups compared to other ethnicities. So that's kind of how we use it. So for this, we go back into our spreadsheet. We've got some data I've already pulled for you to try and speed this up. So this has come from the MDAT database again, but this time we've only got data on coastal hazards to try and make things a little bit easier. So I've run a query for coastal flooding and coastal storm, and I've grouped it by continent regions. This is, I know the Americas is too, but this is how MDAT presents the data. So what we have here, this set of data came from MDAT, as did the injured, the affected, the homeless, and the total damage. So this data's come from, just been downloaded straight from MDAT. Some of the other data I've produced, so percentages are just a simple equation, percentage of the deaths. So we're going to need those percentage data to run our equations. And then this data I've pulled down from just Google searches. So the total population in these continents, as true as I went and looked it up, the Americas. So then again, you can see total population in North and South America, Asia, Europe, etc. And again, I've put that into percentage data so that we can make a comparison. And same, just looked up data for GDP. So it's a combination of data there, right? Once we've answered our first question on what the chi-squared test shows, and you can click on this link here to find out a bit more about, or re-listen to the intro. We've got 3 key questions, and we're going to copy that. Once we calculate our values, we're going to put it into this table here. So the first question is, and I'll go through this with you, is there a match between the population of a country and the number of people that die from coastal hazards? So the data we're going to need for this is the total population, and that should be continent, really, because we're not looking at country. So again, just think how easy it is to make mistakes in these things. So we can say, is there a match between the population of the continent and the number of people die from coastal hazards? So we would expect that the countries with the highest population have the most people die from coastal hazards. Countries with a lower population have less people who die. So this is what this test is going to kind of tell us, how well those categories are associated or match. So to do this, I'm going to need my total population, and I'm going to need my total deaths. But I'm using the percentage data for this. So I'm just going to create a new table here. We'll have the continent, population. Oh, need to remember paste special, paste v values, because this is kind of an equation that if you move the cell, it changes the equation, all the rest of it. Likewise, I want my percentage of deaths. Okay. Now what I suggest you do, I'm going to merge some cells together to make this easier. I'm going to go on to insert. I can copy and paste this, but an easier way to do it is if I insert image and I happen to want the chi-squared formula. Boom, that's the one I want. Insert that. It should be nice and visible. I can always make it bigger if I want to by including more cells. Okay, so what I've got here is the total population. So this is my expected, and this is my observed percentages. So 16% of the world's population are in Africa, but only 1% of the deaths occur there. 13%, 7, 59, 90%. So again, we can start to see that this it not necessarily a match here. So what I need to do first of all is I need to do this equation here. So equals O, open brackets. Actually, we'll add in a second set of brackets later in a minute. Observed minus the expected, close brackets, and square that. So our hat and squared. Now I'm going to put that whole expression into brackets. I then want to divide the answer to that whole by the expected again. Okay, that's how this formula works. So now I've got the observed data minus the expected data squared divided by the expected data. So I can hit enter. Here's my value for that. And I can copy that down for all of my cells. Okay, so the next step, because my chi-squared value, x chi-squared, is going to be the total of that. So I want the sum of these cells, enter, and I get 41.99. Again, I can do get rid of some decimal places there. Let's go to one decimal place. I'm going to copy that back into my table. So my chi-squared for death toll and total population is 42. Right, now I need to look it up on my table and see if that is going to be significant. So I need to know the degrees of freedom. Okay, so degrees of freedom equals n minus 1. Okay, where n equals the sample size. So let's go back to my spreadsheet. Here, my sample size 1, 2, 3, 4, 5 is 5. That's my n. I've got 5 bits of data. Okay, so my degrees of freedom is going to be 4. So back to my stats. So 4. Okay, I can clearly see that 42 is much higher than all of the values here. So if I look at this one, it's 99. This tells me there's a 99.9% chance that there is something else going on with that data. The data does not fit with the expected pattern. Now, that could well be because some of those countries have different coastlines, for example. So the population of continents and the death toll from coastal hazards does not match as a set of data. So we can have a go at doing that for the economic cost. So again, the GDP, and it would be, we would expect, in this case, so we do the same thing. We should probably label this. So if I just join these together, like I said, that is F toll, and it's important that I make it really clear what parameters I've used. So I've put total population and observed deaths. Okay, now again, as we said before, it's important that we get to make that really clear, so that if people want to see where we got that data from, they can, we are making lots of assumptions, of course we are, but for now, so we want to do the same thing: expected, observed. So this time, our observed is going to be the cost as percentage. So what percentage? Paste special, paste values, and my expected is going to be my GDP. Okay. Paste values only. Again, on my equation, so equals. I can just check back down here if I need to, but my equation is going to be the expected, the observed, minus the expected squared divided by the expected. Looks like that's going to work. I can copy that down, and I can then do my squared sum. Add up those ones for me, please, spreadsheet. Excellent. There we go. Add them all up again. And look, this is going to be the same degrees of freedom, so it's going to be way over that number, which means that we can say that there is not, that those data sets do not match. That is not the expected. So there's something else influencing the GDP. So that could be the level of development. It could be lots of other factors there that mean it's not. Okay. So good luck with that. I hope it all makes sense. As always, if you have any questions at all, please just ask.